Welcome to Quadratics Part 11, and this is the video where I'm going to show you how to derive the quadratic formula from completing the square. We have the quadratic formula here, we've used it, we know it works. We know that we can find the two values of x that solve this quadratic equation, where a, b and c are numbers that could be positive or negative. Yet many people use it but don't know where it comes from, how it works, why it works. We're going to look at all of that right now. So starting with the general form, of the quadratic equation, I'm going to divide everything by a. Okay, so I'm going to begin with getting this x squared plus b over a times x. Okay, plus c over a equals 0 over a, if you like, but obviously 0 divided by a is just 0. Okay, that's the first step. Now I'm going to complete the square for this. Okay, now what I'm going to do is take half the x coefficient. Now half of b over a is b over 2a. I'm going to add that to x and square it and see what I get. But I'll do that over here in a different colour. So what we're going to do here is x plus half the x coefficient, which is b over 2a, and we're going to square that whole thing. Okay? And that comes to, well, I could put a pair of brackets side by side and show the full working, and maybe on this occasion, because of the complexity of it, it might be better to do that. So x plus b over 2a times itself, okay, because that's what it means. And we should know that the b over 2a times x is going to be both the outer and inner terms, and they combine together. But let's do the whole thing. So it gives us x squared using the first term. All right, so we've got x squared. That's from the first terms multiplied together. Okay, I'll show you quickly what I've done there. So it's that times that. Then I've got my inner and outer terms, which are going to give me b over 2ax, b over 2ax, and b over 2ax, which is 2b over 2ax, which simplifies to b over ax, because the 2's cancel, plus my last terms, which are going to give me b over 2a times b over 2a, which is b squared over 2a times 2a is 4a squared. Okay? So the residue, the leftovers, if you like, is this bit here. Okay? So what I'm really saying here is that if I take that away, I'm left with x squared plus b over ax, which is the first part of this. Okay? So I can now go back over here and say that this is the same as x plus b over 2a all squared. That's the perfect square. Okay, but from that I need to subtract my b squared minus b squared over 4a squared, and I need to then add the last part of this, which is still there, the c over a. Okay, and that equals 0. Now, the next thing I do is I move all this stuff across to the other side. I can either do that now, or I can do one more thing first, which I tend to do next. So I'm going to leave the first part alone, and I'm going to put the second part of that into a single fraction. In a moment, you'll see how it works. This stays as it is over 4a squared, okay? But what I'm going to do with the other fraction, the c over a, is I'm going to times the numerator and denominator by 4a, okay? So the c becomes 4ac, and the denominator, which is currently just a, becomes 4a squared. In other words, I'm making the denominator match this one, okay? And the reason I'm doing that is I can combine these to a single fraction. So I get next this, okay? Now you just have to be very careful at this next step, and you'll see what I'm going to do. I'm going to put a minus sign there, and I'm going to put b squared minus 4ac, okay? And all of that is going over to 4a squared, okay? 4a squared. Now, you may be looking at that and noticing that that plus sign has apparently changed to a minus sign. Well, it has for good reason, because what we've done here is by putting this fraction line in here, we've effectively put a bracket round all of this, okay, and turned it into a single entity, if you like. Now, because this was minusing that and adding that, it's now minusing that and minusing the negative of that, which gives us a positive, you see. So minus minus is effectively the same as the plus there. So that is necessary and correct. That, of course, equals 0, as does that, because it's still an equation. Okay, so moving on from that, we can say that x plus b over 2a all squared, right, equals, now, so I'm just simply adding all of that to the other side, equals b squared minus 4ac, okay, and all of that is over 4a squared, okay. Now in a minute it gets really quite smart, this does, because what happens next is we square root both sides, okay, and if we square root both sides we're just left with x plus b over 2a. Okay, that's the square rooting a squared takes you back to just what's in the bracket. And I can take the bracket out now, but I must square root this side. But I could just put a big square root sign over the whole thing. But actually what I'm going to do is square root the numerator first. So it's the square root of b squared minus 4ac. And certainly by now you will be noticing some aspects of the quadratic formula here. And all of that is divided by the square root of 4a squared. Well, the square root of 4a squared is 2a, because 2a times 2a is 4a squared. So this is over 2a. Okay? Now I'm going to move across to here. I'll put another column divider in here. Okay? And what I'm going to do is move across to here and continue this. So I'm now going to subtract b over 2a from both sides. So I'm now left with x equals minus b over 2a. Okay, because I've moved the b over 2a from here to the other side. And I'm going to also introduce on the square root a plus and minus there. Okay, and this becomes minus b over 2a plus or minus the square root of b squared minus 4ac, okay, also over 2a. Okay, so that is also over 2a. And I think you can see that we're nearly there, because what I've got now on the right are two terms, both of which contain 2a on the denominator. So combining that into a single fraction would give me x equals negative b plus or minus the square root of b squared minus 4ac. Okay, and all of that is divided by 2a. Okay, because it's a common denominator of 2a in both of those terms, you see. So I just need to extend that fraction line all the way through and right underneath there 2a. And I'm sure you've noticed that is the quadratic formula. Okay, so it really does work. That is where it comes from. It's not just sort of imagined. It has roots, it has a basis, and there it is. And that is the quadratic formula that we use, and hopefully now can use confidently, knowing that you understand its origins. Okay, so I hope that's been helpful and informative, and it should be completing your knowledge of quadratics. Thanks for listening. Take care.